Okay, all right. Today we'll be trying to classify a few things. Okay, so we'll be classifying images in this class. Welcome everyone. If you can see me, if you can hear me, please let me know in the chat. I am also trying to see if I am audible, if I am visible. Okay, all right, there you go. So let's just quickly get started. First of all, what I'll do is that I will just take you through what image classification really is. So in the last class, what we did is that we tried to classify between dogs and cats. In this session, particularly, we'll be trying to classify the MNIST data set that you have. So an example of that I can show you right now. It's very simple actually. We have this website that will give you a live demo of what we are trying to do here. So what is MNIST? MNIST is just a data set, okay? Just a data set which has a lot of images, and those images are just handwritten digits that you have from 0 up till 9. Now, what is the benefit of doing that? Well, that will just teach you how to, basically predict what digit has been drawn on the screen. So we can just say something like 1, and you can see that 1 has the highest confidence, right? So that's what you can do. Clear this, make it like 2, and this is how it would look like. Okay, 3, and we can have 5 as well. So that's how this thing works. If I just make it like this, then it thinks it is 2 as well. It can be 5, it can be 6 or 8. If I make it look like an 8, I think then it would say, okay, so currently the model thinks that, okay, it can be a 2, it can also be an 8. So these things are there, but we'll try to understand how can we predict these digits. So how is this actually happening? How does this prediction method work? We'll try to see and we'll try to understand everything about this. All right. So for this case, we'll be using Keras from TensorFlow, and we'll try to build this model up from scratch. And let's quickly get started. I hope you understood what I'm telling here. Basically, we'll just take a data set which has a lot of photos of handwritten digits from 0 up till 9, multiple versions of a particular number, like there'll be multiple versions of 0. So it can be something like this is a 0, this is a 0, right? So all sorts of zeros they'll try to make, and they'll show you this is what 0 looks like. You have 1, you have 1 like this as well, right? So there are all sorts of ones that you can write. 2 like this, you can make 2 like this as well. So all of those are possible, and we'll just see how to make it happen. So this was just an example. I'll just close this right here, and I'll open up my Google Colab. So if you don't know, Google Colab is just basically what we use to just predict, just like build a model essentially, right? So I'll just click on Google Colab here, and yeah, so here, first of all, I'll just click on new notebook itself, and let's just let this thing load in. Okay, so this thing has loaded up. I'll just click on connect here. I'll zoom in. Let's just see if that thing is working, connecting. So essentially what is happening here is that this file is getting connected to a server on Google, and so basically whatever computations we'll be doing will be done on their servers. And so the laptop that we are using right now can be whatever laptop we have. Manan, welcome to the class. Hello bro, you're amazing, thank you so much. Right, so let me just check. Okay, so there are 3 people watching this right here. Guys, if you're enjoying this, make sure that you hit the like button as well. Okay, we'll try to build a simple CNN. Okay, we'll just try to build a simple convolution neural network, which seems like a complicated term, but it's actually very simple. Okay, so what I'll do here is that I'll just yeah, let's just continue now. The first thing that we will do over here is that we'll just say that from keras.datasets, okay, from keras.datasets import MNIST. All right, Next one would be import numpy as np. We'll let this run up, and in the next cell we will just we will divide this data set into multiple segments. So the first segment would be for training it. So they would be like a train data set. They would be a validate data set for which we'll be using it to validate and see what the accuracy is of our model. And the last one would be that of a test one. So that is what we'll use to see how good the model is actually doing. So how do you do that, right? So we'll just say x underscore train, y underscore train, and then we'll just say x underscore test, y underscore test. Okay, so we have that over there. The next part, let me just see. Yeah, the next part would be to just say mnist.data.load data, actually load data right there. Have that curly braces or like simple brackets, and just execute this as well. So let's just see, it is saying downloading data from storage, Google APIs, TensorFlow. This thing might take some time. Let's just see how long does this actually take. Okay, let's move ahead. Let's look at something else. Let me just see. Okay, so now what we'll do is that in the third cell that we have, we'll try to see what a MNIST image actually looks like. Okay, so what does a handwritten digit look like in this data set? We'll try to see that. So first of all, we'll just say import matplotlib.py plot as plt. Then we'll just say print, and we'll just say training data sample. Okay, and then we will just say plt.img.im show. Okay, not img, just write im show, and put in 4 over here. Okay, so first of all, we'll say x underscore train, and we'll just do 4. That is the 4th index. That would be the 5th object actually. So we can get information about that. And the next one is going to be just plt dot show. Okay, plt dot show. Then we will just say print label of this image is, and then we can just put in the y train that we have, right? So y train, and we'll get the 5th one, that is from the 4th index itself. So I'll just run this and see what happens. As you can see, we get this 9 here. This is what 9 looks like, a handwritten 9 digit. Now one thing that you will notice is that this is not in black and white. Okay, so this is having a yellow color, it has a green color as well, and the background is violet or bluish, right? So it's not like a black and white mixture that you have here. Let's just keep moving ahead then. Next part for us would be to basically reshaping the data. Okay, so here what we'll say, we'll just say x underscore train is going to be equal to np dot reshape. Okay, so np dot reshape, and we'll say x underscore train, and comma, we'll put in the actual number. So we'll just make it -1 28 comma 28 comma 1. Well, basically what I'm doing here is that I am making sure that the image is only about 28 into 28 pixels, and let's just go to the next line, and here I'll just say x underscore test. Everything would just be the same. I'll just have the same thing, so I'll just copy this right here, and after that I'll paste it over here, x underscore test, and here we have x underscore test. Okay, so that's done. Now moving on to the next part. The next part would be to just have x underscore train dot shape. okay, comma x underscore test, right? So x underscore test dot shape, comma y underscore train dot shape, comma y underscore test dot shape, right? This is what we'll be having at the very end. We can just print this and we can see what it would look like. So now this is the data that we have with us right now. Let's move ahead. The next part would be to basically normalize everything. So what is happening right now is that all of the RGB values, right? So whenever you have like a RGB value, the value is between 0 and 255, right? So if I just search for RGB color, RGB values, and you can just go into the images and you can see that there will be multiple values that you will have, right? So an example can be something like this, as you can see. So by varying the numbers, the red intensity, the green and the blue intensity, we are changing how the end goal would actually look like. So just understand this right here. I'll just close this again and I'll open up, I'll go full screen right here. So what we need to do here is that, yeah, here I'll just normalize it. So what I'll do is that I'll take that number, whatever number I have, and I'll divide that by 255. So previously I was having I was just having values between 0, 1, 2, 3, dot up till 255, right? That is what I was having. Now I have divided all of these values by 255. So what will happen next is that I'll have values that go from 0 to 1 upon 255, comma 2 upon 255, comma 3 upon 255. All right, and just on and on and on like that. And we'll just say at the end we'll be having 254 upon 255, and we'll have 255 upon 255, that would be 1, right? So this is what we have here. Very simple. I'll just clear this up. This is what we have to do. How to do that? That is very simple. We'll just say x underscore train, and that would be equal to x underscore train by 255. Next part, we'll do the same thing over here as well. I'll just copy this actually, and I'll put it next. I'll change this to test, and I'll do the same thing over here as well. So I will change this to test as well. Execute this. Okay, the next part would be to actually do something called as one hot encoding. Okay, now what does that mean? You don't need to worry too much about it, because again, that is the part that you will understand when you have understanding about linear algebra, and once you get into like 11th 12th grade, that is when you'll be able to understand how that really works. But it's very simple, nothing too difficult. I'll just lay out the code for that and you can just copy it, don't worry about it. Okay, so I'll just say from keras.utils.np underscore utils import to categorical. Okay, then you would just say y underscore train is equal to 2 underscore categorical, and then we'll just say y underscore train comma number of classes that we have, num classes equal to 10. Okay, and I'll do the same thing for the test as well. This was for the train one. I'll do the same thing for test. Supposed to be 10 here. Make this 10, and we'll go here, we'll get rid of this and we'll just say test. We'll do the same thing over here as well, make it test. Okay, we're done. Let's go to the next part. Then the next part is to import the model. So we'll start by saying from keras.model import sequential. So the sequential is a very simple neural network model that we have just taken from there, and now we just need to add a few things. So first of all, we'll initialize the model. So we'll say model is equal to sequential. Okay, so now we have sequential as the model. Then we will say from keras.layers import. So we'll be importing a few things here. First of all, we'll be importing conf2d, right? So this is just for our 2D images that we have. Next, we'll have max pooling 2D, right? Don't worry what that really means. It's a function that they have, max pooling 2D. Then we want to use something called as flatten. That's just a function to make sure that the value doesn't really approach like infinity or something, or some huge number. Then we have something called as dense. That's just when we need to create a new new layer that we want to have. We'll use the word dense. I'll show you how that happens. And the last is going to be dropout. Let me just see. Okay, so we don't need to have this right here. Let's run this, and it works. Okay, the next part is going to be this thing. We'll say model dot add. This would be conf2d, and then we'll say 32 comma kernel underscore size, and this size would be 5. The strides that we'll go to, that would be 1. Then the padding here is going to be same, and then the activation is going to be ReLU. Activation is going to be ReLU. Now, if you don't know what ReLU is just a function which says whenever I have a negative value, make that negative value equal to 0. And whenever I have a positive value, don't do anything with it. Okay, so y is equals to x when x is greater than 0, when x is less than 0, then y is equal to 0 itself. So that's what you need to understand here. That's what ReLU basically is. Then we'll say input underscore shape, and here we'll just put in what is the shape that we want to go to. So we want it to be 28 into 28 into 1. That is just the height, weight, and like breadth that we want to go to. Let me just run this right here. Okay, the next part is going to be to basically continue doing a lot of these things. So we'll just say model.add max pooling 2D, and we want the padding to be the same. I need to like put it over here as well. Just take this and I'll put it over to this place, and I'll copy this. I'll put it over here. Okay, so this is what we have right now. I'll just get rid of this. We don't need that. Okay, so here we need to change a few things. First of all, we'll be having a 64 as in the second layer, right? So this would be 64. The kernel size would be 5, strides would be 1. Everything looks the same. We won't have this over there, so we'll get rid of that. But yeah, everything looks good to me. All right, in the next one, we would have max pooling. The padding would be the same. Then we'll say model.add flatten. Okay, model.add flatten, and we would actually have this as well. Okay, the next one is going to be model.add dense actually. So we'll get rid of this here. We'll say model.add dense, and we'll put in a few things. First of all, this is what we want to have. We want to have 1024, and the activation is going to be ReLU. Okay, then again we'll have model.add. We want to drop out, and that would be equal to dropout. What do we want to drop out? We want to drop out 0.2. Then we'll say model.add, and we'll put in dense 10, activation would be sigmoid. All right, now I will just run this and let's see what do we end up getting. Let me check what the time is over here. Okay, so we do have some time right now. Okay, everything loaded up as we wanted it to. Next, we just want to compile the model. So we'll just say model.compile, model.compile. We'll put in a few things like optimizer that we want to use. That would be an Adam optimizer. Don't worry if you don't know what that means. That's just a way for us to improve upon the performance of our network, right, of our CNN. Then we'll say the loss function that we have, that would be categorical cross entropy. Categorical cross entropy. Then we'll have the next part would just be the metrics. So the metrics would be equal to like what do we really want to improve? So we want to improve accuracy itself. Okay, accuracy. That's it. Let's just run this, and now we want to train the model. So we have the model ready, we just want to train it now. So we'll just say model.fit. Okay, model.fit, we'll just say x underscore train, y underscore train. Then we have the batch size as well. So we want it to be in batch sizes of 100. Okay, the epochs that we'll be having would be about 5 epochs. That is just how many revisions do we want, like how many times we want to repeat. That is a number of epochs. Then we want to have validation data, and that would be equal to x test, y test. Right? So against what do you want us to test it? So we have y test as well here. All right, let's just run this and see what do we end up getting. It's going to take a few moments, I think, and then it would be ready. Any questions you have, I'll just take your questions. Will we be having Keras, or do we have to download it? Which ID are you using? Okay, so look, what I'm doing here is that this is a Google Colab. Okay, this is Google Colab that I'm using, and currently we are actually training the model. But basically, this is called as Google Colab, right? So here what you can do is that you can actually build models, and you can use this to actually like create machine learning models. Now you don't need to install anything actually. Just open up Google Colab. Just go to collab.research.google.com. Okay, and here you have this Colab. You can check whatever file you want to open up, but you can also just click on cancel here, and you can open up a code and you can start coding in over here, right? What I'm using is Python, and I understand you might not be able to understand what is exactly is happening here, but basically I have explained all of this in the courses that I have on the Unacademy platform. You might not have seen those, I completely understand. Right, so yeah, this is going to take some time. As you can see, there are about 600 images over here, so it's just going through all of them, and we have 5 epochs, so we'll be doing this 5 times over. So this will take some time. I'll just take your questions if you have any then. Look, the way this works is that if you are having some doubts about what is happening here, how exactly is everything working, so look, first of all, I'll just make it like this. Yeah, so I'll just revise whatever we did. We first of all go here and we import a few modules that we'll be using. Okay, the next part is going to be to actually get the data set. So we imported the data set by saying keras.datasets import mnest. After that, the next part that we did is that we imported numpy, then we segmented the data set into test and to train basically parts, basically, right? Then what we do, we just try to see what data do we actually have here. So I can just go and I can make it like, can make it like 30 as well, and I'll be able to see what this is really going to be. So if I try to run this, let's see. Basically, this is just showing us that, okay, this is what this data is about. This is what this image is about. Okay, so yeah, it's taking some time, but well, after that we basically reshape it. So whatever images we have, we want to make sure that the images have the same pixels and all. That's why we are doing it. And here we take all the RGB values and we convert those values from 0 to 255 to 0 to 1 by dividing the complete range by 255 itself. Then we'll just actually do something called as one hot encoding, which you don't need to know much about, and like how that works. Don't worry if you don't understand that. The next part is going to be to import sequential. So this is how we create a network. This is how we create a neural network. Okay, and in this case it's going to be a convolution neural network, right? And we just initialize the network. We just say model is equals to sequential, and then we import some important functions here. So we have first thing is called as conv2d, then we have max pooling 2d, flatten, dense, and dropout. Okay, that's what we have. Then we basically create two layers. We have two layers, and then we just add a flatten, and after that we will just like yeah, that's pretty much it. We have a sigmoid function as well. If you don't know what sigmoid is, you can just see the graph of sigmoid. Let's just go to see the graph of sigmoid function. Yeah, so it's just like this is how the function would look like. Okay, so it's just like 1 upon 1 plus e raised to power minus x. That's what the function is all about. As you can see, this is how it behaves. This is how the graph looks like. So we want to convert everything to look like this. Hi Shreya, welcome to the class. Okay, that's what we are trying to do over here. What is this? Well, basically, this is a model that I'm making to recognize handwritten digits. Okay, so we have some data. We have a bunch of images. As you can see, this is an example of an image that we have of a handwritten digit of 9. Okay, I hope you can recognize this as 9. And then what we say is that we just say that, okay, this is the data, and I want to get to predict this data. Okay, predict if this is a 9, if this is a 1, this is a 2. That is why we made this thing happen. Now this will take some time, and I am out of time right now. So what I will do is that I'll show you an important thing that you need to keep in mind, and that is you can ask doubts on the Unacademy platform, right? So what you can do is that you can ask whatever doubt you have, and your doubts will get answered by the faculty that we have, the educators that are available on the platform. And you can just take a picture of whatever doubt you have, you can upload it, and we'll be able to answer your doubts. You can also get the Unacademy subscription, with which you can attend pretty much any class on the platform. You can learn whatever you want to learn properly in live classes from amazing educators. You can also take live tests, and there are new batches starting every single Monday. This is the pricing of Unacademy subscription. As you can see, we also have an iconic subscription with which you'll get access to a lot of features, like you'll get a personalized mentor as well, so that you can learn properly. And this is the pricing for the iconic subscription from Unacademy. And the next part is that you can actually avail a 10% discount whenever you use the code ISHANYT10 for any of these subscriptions, right? So both the normal Unacademy subscription and the iconic subscription. Okay, that's it. We also have some scholarship tests coming up called as Unacademy Combat for class 10 students. And we also have this revision series that is happening to get you ready for the exams. Again, you can download the Unacademy app. Just go to Google Play Store or App Store. Just type the code ISHANYT10 to get a 10% discount. Right, let's just see if the model has trained. So only one epoch has trained. The other ones are taking time. This one took about 449 seconds. Right, so roughly about more than 5 minutes actually. That took a lot of time. Okay, So yeah, that's pretty much it. Thank you for joining me here for this session. You can just let this model run. It will train properly, and at the end you can just say something like this. You can type this command model.evaluate, and you can put in x underscore train, comma x, comma y underscore train, right? And then you can say something like yeah, so x underscore train, y underscore train, and after that you can say comma model dot evaluate x underscore test, comma y underscore test. All right, so that's what you can do to just see what are the results, if it is able to properly predict the digits or not. That is what you can do over here. Thank you for joining me here for this session, and I'll see you in the next one. Okay, bye bye.